Let's first talk about the cross join, because you can think of the cross join as being the first step for all the other types of joins. And what the cross join does is implement a Cartesian product. Sounds complicated, but it's actually a very simple idea. Imagine, for example, that you've got two tables, and each table has a single column. Let's call the first table T1, and it's a table that has a single column, and it has 3 rows, and the values that are stored are 1, 2, and 3. Now let's imagine the second table. Let's call this one T2, and it also has a single column, and it has 3 rows as well, and the values are A and C. Now the Cartesian product between T1 and T2, sometimes written like this, is simply each row from table 1 combined with every row from table 2, every possible combination of the 2 rows. So for example, the result is then 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, and 3C. Every row from table 1 got paired with every row from table 2. And that's called the Cartesian product, and that's exactly what a cross join does. You can see here that we get 9 rows of our output, and that's because 9 is the result of 3 rows from table 1 multiplied by 3 rows from column 2. When you do a Cartesian product or a cross join between 2 tables, the number of rows in your output will be the number of rows in the first table multiplied by the number of rows in the second table. Let's look at an example, and let's cross join the film table with the store table. And the way you write a cross join is you say cross join store. Let's have a look at this output. You can see that we got 2,000 rows in our output, and that's because the film table has 1,000 rows and the store table has 2 rows. And if we scroll along and have a look at our output, we can see that the columns just start off being the film table columns, and then we get to the columns from the store table: the store ID, the manager staff ID, the address ID, and the last update. So film ID 1 got paired up with store ID 1. Film ID 2 got paired up with store ID 1. Film ID 3 got paired up with store ID 1, and so on. And you can keep scrolling all the way down. And you can see that eventually you get to a point where now film ID 1 gets paired up with store ID 2, and so on. So every possible combination of film ID and store ID row got joined together, and that's a cross join. So this from statement has now returned a table with columns from both the film table and the store table, and we can select on those if we want. So we could select the film ID, and we can select the store ID, and we can even order that output too. So we could say order by film ID, store ID. Let's run that. And this makes the different combinations that got created a little bit clearer. Film ID 1, store ID 1. Film ID 1, store ID 2, 21, 22, 31, 32, and so on, all the way down, and there are 2,000 rows in our output. Let's write another query now, and this time let's cross join the customer table with the staff table. And we'll just select all of the columns, run that, and let's just have a look at the different columns that were returned. We have columns from the customer table, and then we have columns from the staff table as well. Let's select the customer ID and staff ID. And you can see that works just fine. Now let's also try and select the email address and see what happens. We get an error, and it says the column reference email is ambiguous. Let's have a look at our relational diagram to understand why this didn't work. So just remember, we're cross-joining the customer table with the staff table. Notice how in both the customer table and the staff table, there's a column called email. So when in our query, if we just have a look at it again, when in our query we were selecting the email, the error we got back was telling us that it's unclear which column we want to pick. Do we want to pick the email column that originated from the customer table, or the email column that originated from the staff table. In our cross-join result, we actually have both. What you often need to do then when you're working with joins is actually to qualify the column names with the originating table name. And it's generally a good practice to do this for every column that you're working with, regardless of whether you're doing it in the select clause or whether it's in the where, group by, having, and so on. So what we would do then is rather than just saying select the customer ID, we would say select customer.customer ID. We would say staff.staff ID. And for the email, let's say I actually want to just show the customer's email. So I'll say customer.email. And I can run that query, and that works. Because now there's no ambiguity. I've properly, fully qualified which email column I actually want. And of course, I can now also add on the staff email by saying staff.email. I was able to select the customer ID and staff ID columns without fully qualifying them originally, because customer ID only lives in the customer table, and staff ID only lives in the staff table. There was no ambiguity. Generally speaking though, when you're working with joins, you're almost always better off fully qualifying your column names, just to avoid any of those ambiguous situations. And this is also why it's quite useful when you're working with joins to start to use what are called table aliases, just to reduce the amount of typing that you have to do. And you would be already quite familiar with the concept of aliasing, because you've been doing aliasing a lot already in your select statements. Now we just apply a similar concept, but we can alias tables. So I'll start to refer to the customer table as C, and I want to alias the staff table as S. Now I can come up here, and wherever I've written customer, I can just write C, and wherever I've written staff, I can just write S. And I can run that query, and I get the same results. When you're doing joins and you're working with multiple tables, it's very common that you'll see table aliasing done in this way. And it's just to reduce the amount of typing that you have to do, because you generally speaking now want to fully qualify all of the different columns you refer to. Finally, throughout this course we've been using this star wildcard a lot to refer to all of the different columns. You can also use table aliases with star, so if you just wanted to select the columns that were originally from the customer table, you can do c.star, and we just get the ones from the customer table. Or you could do s.star, and now we get those columns that are just originating from the staff table. There's an older syntax that you'll sometimes see for doing cross joins. It's quite common on the internet just because a lot of SQL code on the internet is quite old and out of date. The older syntax for doing cross joins is just to put a comma between the two tables, and you can run that and you get the same output. Throughout this course though, I'm going to be using the modern syntax, which explicitly spells out cross join. Okay, so it's a pretty simple idea, isn't it? A cross join just gives you a Cartesian product between two tables. You don't tend to use cross joins too often when you're writing SQL, but I think it's really important to understand a cross join because the following joins that you're going to learn about, inner joins and outer joins, are just a cross join with one or two extra steps. So with that said, let's now head over and learn about inner joins.